Today we have here another nice integral from the MIT Integration Bee 2016, number 18. We have the integral from pi over 3 to pi over 2, 1 minus cosine x over sine x dx. Okay, we do have a very straightforward way to do this. One thing you could do is you could just multiply the sine x into the numerator, split it on the minus sign, you'll have two integrals. You'll have the integral of cosine x minus integral of cotangent x. But what I noticed on this is actually a pretty good opportunity for me to use the Weierstrass substitution. Okay, now for this method here, this is probably a little bit longer, but what I did do is write out all of our formulas here. This is derived, everything down below is derived from this first substitution that we're setting t equal to tan of x over 2, even though we don't have that in our expression. So it is a little more complicated to derive just because it's not a standard use substitution and we have the half angle here. If you need some more information on where all these formulas came from, I've derived them in previous videos, so I'll provide a link in the description. Now to get started with this, first let's just update our bounds. So plugging pi over 2 in here, we're going to have tan pi over 4. That's just 1. Plugging in pi over 3, that's going to be tan of pi over 6, which is just going to be 1 over square root of 3. You can also write that as square root of 3 over 3. Then doing the numerator, we're going to have 1 minus our cosine value, which is this. Then for our dx, the 2 in the dx, I'm going to bring that all the way up front. Then we're going to have a dt over 1 plus t squared. Then the denominator is just sine x. We'll use this stuff over here, 2t over 1 plus t squared. Now from here, we just need to clean everything up. Now clearly this 1 plus t squared is going to cancel with this, but I actually want to clean up the numerator as well. What I can do is multiply in, let me make a little space. I want to multiply in a copy of 1 plus t squared in the numerator as well. Of course, we don't want to change it, so we need to multiply an extra copy here. So now we can distribute everything in and see what happens. So let's see, we have our 2 up front here. Multiplying this in the numerator, we're going to have 1 plus t squared. And then this is going to cancel with this here. And we distribute in the minus sign here, so we're going to be minus 1 plus t squared in the numerator. And then in the denominator, one of these copies I can cancel with one of these here. And we're left with, I think I'll just leave it like this for a second, 2t times 1 plus t squared. 1 minus 1 is 0 here. T squared plus t squared is going to be 2t squared. But then I can cancel out 2's, I can cancel out 1t, and I think we're left with an integral here we can do. Now just to set this up, let me take this 2 and multiply it back in here. So we're going to have a 2t here in the numerator. And now I think we're set up for another substitution. Let's do a u substitution and get rid of all the Weierstrass stuff. So for this substitution, I'm just going to substitute for the denominator. I'm going to set u equal to 1 plus t squared. Take a derivative, so our du value is going to be 2t dt. So the du value is exactly what we have in the numerator. So we'll go ahead and substitute this. First, updating the bounds, plugging in 1 for t. That's going to be 2 for the upper bound. Plugging in 1 over square root of 3. When you square it, it's going to be 1/3. 1 plus 1/3, lower bound becomes 4 over 3. But then this whole integral, it just is going to boil down to just du over u. Integrate this, we're going to have just natural log. Absolute value I'll drop because everything's clearly going to be positive, so we're just going to have natural log of u evaluated from 4/3 to 2. Evaluating this, we're going to have natural log 2 plugging in the upper part, then minus natural log of 4 over 3. If I use the minus to turn this into a fraction, we'll have natural log of 2 over 4 over 3. I'll flip it and write it as 4 in the denominator and bring the 3 into the numerator here. Cancel 2 with 4. And for my final solution of this, we just have natural log of 3 over 2. Okay, so there you have it. Works out pretty well with the Weierstrass. Probably not as well as if you did it some other way, but still really not too bad. Anyway, thanks everyone for watching today. Have a good day.